Well, welcome to the mole unit. And the mole unit is basically a continuation of the chemical reaction unit we just finished. But however, we are adding a little bit to. We're diving a little bit deeper into the realm of chemistry. And we are going to especially look at chemical reactions a little bit deeper. So the concept is still chemical reactions. Underline. Oh, not across here. Underline. All right. However, we are not dealing with qualitative chemical reactions anymore. And what I mean by qualitative chemical reactions, I mean the question saying CH4 methane gas reacts with oxygen gas to give you CO2 gas plus hydrogen, or H2O gas. Alright, and then we would balance the equation, 2 there, and a 2 there, and we would leave it at that. However, now, in the mole unit, we are actually applying numbers to this equation. Exactly, instead of just methane gas, we will say 5 grams of methane gas reacts with 8 grams of oxygen gas, and it will give me 2 amounts of CO2 and H2O. I don't know why I'm talking like that, but I'll kind of stop and talk in my normal voice. But it's not as epic as I put it out to be. But basically, we're just putting number values. So quantitative meaning number, qualitative meaning just write out the equation and balance it. So to do the quantitative math that relates to this part of chemistry, we have to look on the periodic table and find the atomic mass. This is the atomic mass. And the atomic number right there. So that's the atomic number. Alright, so mostly we'll be dealing with the atomic mass. Alright, and we also will call that another thing here. I'll show in another slide. But basically, those are the two things we'll need. So some definitions here that are pretty useful with this unit is, well, basically you have to know what a mole is. A mole is the amount of substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. So why exactly did they choose carbon-12? Well, it's because basically when all this work was being done, it was around the time of the Industrial Revolution, and well, there was a lot of carbon. People were burning a lot of carbon. People were getting a lot of energy from carbon, so it was really, it was really abundant at the time. And so abundant that there was this man named Amido, which is kind of a cool name. I'll write it out here if I could find it. Amido Avogadro came up with using all this research about mass and about how chemical reactions occurred, he came up with a number of particles in exactly 1 mole of a pure substance. And he called his number Avogadro's number, which is 6.022 times 10 to the 23rd. And it could be anything. It could be atoms, it could be particles, it could be molecules, it could be Forsters, whatever you want, whatever you wanted to measure. All right, this is a really, really big number to represent a lot of different particles. And we also have a term called molar mass. All right, so molar mass is using the mole and relating it to the periodic table. All right, so molar mass is the mass of 1 mole of a pure substance, and its units are grams per mole. And the good thing about molar mass is it is equal to the atomic, right, that kind of big there, atomic mass. All right, so the molar mass of helium, spelled that wrong there, helium, don't tell on me. Helium is 4 grams per mole. So I would just look up there and find the atomic mass, and it's basically the same thing. All right, so here let's do an example. So there are a couple different charts that are going to become very useful with this unit. One is converting atoms to moles. All right, so converting atoms to moles, or moles to atoms. So to convert atoms to moles, I want to divide by Avogadro's number. I'll just put a Avogadro's number. And to go from moles to atoms, I multiply. I don't know why I drew that. I multiply by Avogadro's number. Okay, so here, the hardest thing kind of basically about these problems is finding out what I'm going, where I'm starting and where I want to go. All right, so how many moles, so I want to end up in moles, are there in, of silver, are there in 3.0 times 10 to the 23rd atoms of silver? So I am going from atoms to moles. All right, so I need to divide by Avogadro's number. So I take my 0.01 times 10 to the 23rd and divide it by 6.022 times 10 to the 23rd. And I pull out my handy-dandy calculator, which is, I have a TI Smart View right here, so I can do this calculation real quick. So I type in 3.01 second E 23 divided by 6.022 second E 23. Enter. And I get there my answer, which is 0.499, but I want to round this usually to the second or third decimal place, so I'll round this one up to 0.5. All right, so, and that'll be moles of Ag. All right, you always want to put a unit with your number, or your number will be useless. It'll just be a number and be very lonely. So that's one example of our, oh, I made that too big. So that's one example of our chart. So the next example is relating this to the amount of grams of something. So I want to relate moles and grams. All right, so to convert from moles to grams, and from grams to moles to grams, I want to multiply. So multiply by molar mass. All right, so remember, molar mass is, I just add it up on the periodic table to find that, and then grams is I divide by the molar mass. All right, so this question asks, how many moles of aluminum are there in 11.9 grams of aluminum? All right, so I want to take the grams, they give me 11.9, and divided by the molar mass of aluminum. All right, so divided by the molar mass of aluminum, which if you look on your periodic table, the molar mass of aluminum should be about 26.98 grams per mole, and that's in grams. So if I do that calculation, let me whip out the calculator here. All right, let me clear that. The last one. So I do 11.9 divided by 26.98, and I get to 0.44, and I'll just keep that. I have to put the 1 there, the 0.44 moles of aluminum. All right, so moles of aluminum. All right, so that is a gram to mole conversion, and also before that, that is a atoms to moles conversion. So if you have any questions about this, we'll work on some more problems in class or consult the calculator tutorial. All right.